Antarctica, a snowy world of about -46 degrees Fahrenheit, covered in ice for millions of years. But it wasn't always this way. Scientists just found something buried deep beneath the seafloor that shouldn't exist. Tiny golden droplets of amber. This means that Antarctica was once teeming with life and thick with trees. But something happened to it. Something that could reshape the way we see our own future. Antarctica has been a land of howling winds for millions of years. No tree can grow here today. But scientists who studied those lands decided to drill deep beneath the Antarctic surface. They went thousands of feet below the ice, pulling up ancient layers of sediment. And there, trapped in time, they found tiny pieces of golden amber. Amber is basically fossilized tree resin. It's found all over the world, often with perfectly preserved pieces of ancient life. Insects trapped mid-flight, pollen frozen in time. Entire tiny ecosystems can be locked inside golden droplets. In every continent, but not in Antarctica. Until now. They discovered tiny specks from 0.5 to 1 millimeter in size, smaller than a grain of sand, but with huge significance. This droplet had once oozed from the bark of a tree about 90 million years ago. What's even wilder, amber is only produced by certain types of trees, the ones that grow in humid, temperate rainforests and jungles. That's when the realization hit. Antarctica used to be a rainforest. Those tiny flecks of amber, clearly seen only under a microscope, tell us a vivid story of a living and breathing ecosystem. Around 90 million years ago, during the Cretaceous period, when dinosaurs ruled the Earth, Antarctica could have been covered in lush, swampy forests filled with towering conifers, ferns, and ancient plants. Some of the fragments showed signs of damage. That means the trees that produced them had been injured, perhaps by wildfires or parasites. Though despite that, and despite the fact it spent millions of years on the seafloor, this amber was almost perfectly preserved. Solid, transparent, and free of cracks. Normally, amber buried under extreme pressure and heat just crashes over time. But this piece, it survived. That means other pieces could survive as well, and we might find more of them on the ocean floor. But this wasn't the first sign that Antarctica had once been a different place entirely. It started in 2017. A team of scientists drilled deep into the seabed near Pine Island Glacier on Antarctica's west coast. They pulled up sediment cores, long cylindrical samples of Earth that had been buried for millions of years. And it was insane. Inside these layers they found fossilized roots, pollen, spores, traces of an ancient forest that had once thrived here. And that's exactly what they'd been studying ever since then. In order not to damage anything, they had to spend years of hard work, breaking down the sediment into thousands of tiny pieces and scanning them all under fluorescent microscopes. The same team also found another piece of the puzzle back in 2020. They found more sedimentary samples from the ocean floor that pointed to a land of dense trees, rivers, and wetlands. A world that looked more like the Pacific Northwest or New Zealand. But why was Antarctica so warm back then? Well, that's all because of the atmosphere. 90 million years ago, Earth's carbon dioxide levels were terrifyingly high. It was literally one of the warmest periods in history, with temperatures soaring even at the poles. Think about it. Antarctica had no ice caps. Instead, it could have had buzzing insects and maybe even dinosaurs wandering through its forests. But in order to learn what happened to them, the team has to find more evidence. Antarctica really is a place full of mysteries. It's hard to study because it's covered in snow and ice so much that we don't even know its true shape and size. Some parts of the ice sheet are over 3 miles thick, half the depth of the Mariana Trench, the deepest trench on Earth. Luckily, snow has a great quality. It can freeze things in time perfectly. Layer by layer, year after year, it buries nature's past like a time capsule. Luckily, snow has a great quality. It can freeze things in time perfectly. Layer by layer, year after year, it buries nature's past like a time capsule. At first, fresh snow is soft and shifts easily in the wind, full of air. But as more snow piles on top, it compresses, squeezing out the air pockets and hardening into dense ice. This freezing pressure locks everything inside. It traps ancient plants, animals, and even entire landscapes. And they literally get frozen in time, because the extreme cold slows down decay. It stops bacteria growth, preventing rot, and keeping things almost perfectly intact for thousands, sometimes even millions of years. That's exactly what's going on in Antarctica. Scientists have to literally scan it all the way down this snow in order to find what this place looked like millions of years ago. What they found is an entire lost world buried under miles of ice. It was beneath the thickest ice of East Antarctica, near the Aurora and Schmidt subglacial basins. The weight of the ice has been so immense for so long that it actually protected the land from erosion. Scientists call it the ghost of Antarctica's landscape, and it's nothing like the smooth, flat wasteland seen from above. They found rivers that once flowed freely, now frozen in place, valleys carved by water, even 3 massive, sharply peaked hills. But what are they? To understand that, we need to go even further back in time, to the era when Antarctica was still part of a lost supercontinent. Hundreds of millions of years ago, the land we now call Antarctica was part of Gondwana, an enormous supercontinent that included South America, Africa, India, Australia, and Antarctica all fused together. But as Earth's tectonic plates slowly drifted apart, Gondwana broke into pieces. Antarctica was ripped apart, its land stretched and fractured. The massive ice sheets that formed later covered these broken land masses, preserving them like frozen fossils. As the ice shifted and melted over time, valleys formed, and ancient rivers likely carried water toward a coast that was hundreds of miles away from where it is now. But that's not the only thing Antarctica has hidden. If you stripped away the ice, you wouldn't see a smooth, empty continent. You'd see a super dramatic landscape, towering mountains, deep valleys, even fiery volcanoes. In West Antarctica, at least 138 volcanoes are buried under the ice. One of them, Mount Erebus, is still active. And inside, it has warm volcanic caves where you could walk in a t-shirt. Oh, and if it wasn't weird enough, Erebus is also spewing out gold. Yep, the actual tiny specks of gold from deep within the Earth. Scientists believe this happens because magma, the superheated semi-molten rock beneath the Earth's surface, carries liquid gold with it as it rises. Every single day, Erebus releases about 0.2 pounds of it. That's worth around $6,000 per day. In a year, that adds up to 64 pounds, or more than $2 million, floating into the sky. Unfortunately, before we grab shovels, we gotta remember that those are just microscopic particles. They're often smaller than 60 micrometers, thinner than a human hair. Not even mentioning that they're scattered around up to 620 miles away from the volcano itself. Finding them is nearly impossible. But that just shows that even in such a harsh place that looks just like a white desert, there are still many fascinating mysteries to discover. For example, somehow, life still clings there. In 2017, scientists drilled deep beneath the ice of the Ross Ice Shelf looking for water, but they found something fantastic instead. A river hidden beneath 1,640 feet of ice, running through the dark. And inside it, hundreds of tiny shrimp-like creatures. They swarmed around the camera, blocking the lens, welcoming the scientists. In deep caves beneath the ice, DNA evidence has also shown traces of moss, algae, and possibly even unknown tiny animals. So, turns out, even in one of the harshest places on Earth, life finds a way. And who knows what else we'll discover in the South Pole?
Experts explain Africa is splitting in two, and it will look like this. Up close, the process is even more shocking, with a massive crack stretching from Mozambique in the south to the Red Sea in the north. This gap keeps growing every year, tearing apart the land and destroying homes. Now, specialists believe the continent could split much sooner than we expect. Africa is breaking apart because of the Somali Plate movement. Think of it like a dramatic breakup happening with tectonic plates. On the east side, there's the Somali Plate. On the west, we have the Nubian Plate. And during this breakup, the Somali Plate just wants more space, so it's pulling away from the Nubian Plate. This movement is forming the East African Rift, a region where tectonic plates are splitting apart, magma keeps rising from deep below, and a bunch of active volcanoes are being born. So this place is hot, with daytime temperatures that can soar to 130 degrees Fahrenheit, and at night they cool down to 95 degrees. Inside this hot zone, we have the Afar Triangle, also known as the Afar Depression, and its geology is fascinating, as the rifting process is causing valleys, faults, and deep cracks to form in this region. Take, for example, this massive 35-mile-long fissure in Ethiopia's desert. It's also so wide that a person can easily fit inside of it. But what's scary is this crack keeps getting bigger, growing about a half an inch every year. The Nubian and Somali plates moving apart could also lead to a new ocean forming in Africa. This type of process isn't something new. About 150 million years ago, when dinosaurs were still around, a similar tectonic shift created the Atlantic Ocean. The continents were once all clustered together, but when a rift formed in what was Pangaea, it started pulling them apart, splitting the east and west hemispheres. So, a similar thing is happening with this gap in Africa. At some point, experts say the waters of the Indian Ocean might flood the East African Rift Valley, eventually creating a sixth ocean. Now, it's a pity you won't be able to swim in its waters during your lifetime, though. According to geophysicist Ken McDonald, who specializes in tectonic faults, this dramatic rupture could happen in 1 to 5 million years. Trust me, that's considered fast in geologic terms, and way sooner than most experts thought. Now, even though you won't get to watch Africa breaking apart, people there will still see and feel the signs. They might experience intense volcanic eruptions and strong earthquakes as this process slowly unfolds. One example is related to that scary crack in Ethiopia's desert we mentioned earlier. The fissure was created in 2005, after the area was hit by 2 volcanic eruptions and 163 earthquakes, each with a magnitude greater than 3.9. A crack this deep and long on Earth usually takes centuries to form, but in this case, it unfolded in just a matter of days. That's how powerful this event is. In fact, this kind of intense seismic activity can speed up the African splitting process, and that's why it's so hard to predict the exact time frame for the event. What we know is that people are already calling this new land the Nubian continent. If the predictions are right, it will include Somalia, Kenya, Tanzania, and part of Ethiopia. That's exciting and concerning at the same time. As new coastlines emerge, countries will need to make major adjustments when it comes to infrastructure and land management. They might lose a lot of roads, houses, and other constructions currently located near or right in the East African Rift. In Kenya, for example, the fissures tore apart a busy road, and authorities desperately tried to fill the gap with rocks and cement. In another case, an old woman was sitting and eating with her family when her house suddenly split down the middle. Recently, earthquakes that happened near Ethiopia's Afar region demolished 37 schools and forced about 5,000 students to leave their classrooms. Unfortunately, stories like this could become more common over the next few years. But there is a positive side to all this. Countries located in the middle of Africa, like Zambia and Uganda, could gain coastlines, and that might be great for them. Having a coast means they would get access to new trade routes, opening fresh economic opportunities. Plus, think about the tourism boom. With all those newly formed paradisical beaches, these countries could become the next big gateway spot for travelers. The local ecosystem in this newly created ocean will change as well, and new marine species may emerge. So, let's look. This is the path where the rift is most advanced right now. I mean, we expect this is where Africa will eventually get separated. But things could get a little more complicated. Some time ago, Michael Daly, a geologist at the University of Oxford, suggested that this rift could extend further west. And some new evidence backs up his theory, pointing out that the crack could extend south through Botswana's heartland into South Africa, and west through Namibia, all the way to the Atlantic Ocean. If these fractures widened into deep cracks, the ocean might come in and fill the gaps. Experts say Africa could split so much that it becomes an archipelago. But then again, we won't see that happening. It will take tens of millions of years for this to play out. We already know that Africa is at risk of breaking into a bunch of huge islands or small continents. The news isn't great for Madagascar either, as the world's fourth largest island could end up being split in half. But can the opposite process happen? I mean, can new land appear as the Nubian and Somali plates move apart? Well, as these tectonic plates get away from each other, the magma from the Earth's mantle might rise to the surface, and when it cools, it solidifies into new land. That's how other places in the world emerged, like Iceland and the Azores. So, yeah, the same process could happen in the East African Rift, and over the long term, it is possible that the rift could create new islands. For now, all we can say is that the geology of the Afar Depression is unique. It is the most active rift system on our planet. And when I say rift system, I mean a zone where tectonic plates are pulling apart. This region brings together all kinds of events, from faults in the Earth's crust to volcanic zones to the potential formation of a sixth ocean. For experts, it's like studying the evolution of rifts up close. And since it is such an active volcanic area, it also has enormous potential for tapping into geothermal energy, that is, using heat from inside the Earth to generate electricity. 2 geothermal power plants are already producing energy in Ethiopia, one in the Ethiopian Rift Valley and the other in the Afar. Now, geologists are exploring new potential spots. When we look at that deep crack in the ground, we know it's caused by tectonic plate movement. There's no mystery there. But what we still don't fully understand is why the cracks happen exactly where they do. For example, a crack that opened up in Botswana appeared after a magnitude 6.5 earthquake back in 2017. But the epicenter wasn't in the rift zone, where the plates are moving like we would expect. Instead, it was farther south. Since it's unusual for a rift to happen without volcanic activity, this fact really challenges our traditional ideas of how continents divide. Figuring out why these cracks appear in specific spots is still a missing piece of the puzzle for experts trying to explain how Africa is splitting. Hopefully, we get some answers before the continent turns into a massive archipelago.
The South Pole is more than penguins and endless snow. There's a hidden ghost world within it. Look, it's right here on the globe. Don't confuse Antarctica with the Arctic, which is at the top of our maps. Much smaller in size, and, let's face it, way less mysterious. The ice sheet covering Antarctica is about 1 to 3 miles thick, which is up to 16 Eiffel Towers stacked on each other. This massive blanket hides the true features and contours of Antarctica's land. We still don't know much about this mysterious continent, and it is ice and snow that are to blame. We still don't even know the true shape and size of this continent. Mapping Antarctica without some huge shovels is an incredibly hard task. But Satellites learned to penetrate the ice with their cameras. And now we know there's actually an enormous, dramatic ancient landscape beneath the snow. The ghost of the past. About 90 million years ago, Antarctica was a much warmer place. It was actually a lush rainforest with tons of plants and probably teeming with life. It even had rivers flowing through it. Then the ice came. This happened about 34 million years ago, during the transition from the Eocene to the Oligocene, when our planet cooled significantly. It was the beginning of one of our several ice ages. The land remained, but now was hidden under ice and snow that got thicker and thicker. To a regular eye, Antarctica turned into a white desert, vast, flat, and featureless. Time went on. This massive ice sheet moved around, smoothing and shifting the ground beneath it. Over the millions of years, it changed what the land looked like. Now, if we looked under the ice, it wouldn't hold any signs of the original South Pole, except for one place. In areas where the ice is especially thick and doesn't move much, like in East Antarctica, it has actually worked the other way around. It became like a super thick blanket that protects the land. Normally, things like wind or rain slowly wear away the ground over time, changing its shape. But since we have this protective ice blanket, it prevents these natural processes from reaching the stuff underneath. So, the ground stayed almost the same for millions of years, like it's been frozen in time. This special area near the Aurora and Schmidt subglacial basins has become the ghost of Antarctica's landscape. This place was barely touched even since it was first covered in snow 34 million years ago. This is a historical footprint, a place that can tell us what Antarctica's ground looked like before it became a freezing nightmare. As scientists peered under East Antarctica, they saw an amazing ghost. The traces of the rivers that were flowing there millions of years ago, various valleys, and some weird little islands, as well as 3 big chunks of land shaped like the letter U. Hey, what's that all about? You see, the continents on our planet are moving constantly, sliding along the red-hot lava mantle like cereal on milk. Over history, they came together and broke apart several times. Hundreds of millions of years ago, several continents were a part of one enormous Gondwana. Antarctica was one of them. It used to be one huge landmass. But when Gondwana broke apart, the poor continent got stretched by tectonic forces. Parts of land were pulled away from each other. Whoosh! And they got torn apart. And that's how we got these big chunks or blocks of land under thick layers of ice. In any case, scientists now want to explore this ghost a bit more. But to study it deeply, they need to actually drill down through the ice, like using a straw to get to the bottom of a thick shake. This will help them pick up some rocks and dirt from way below to learn more about the Earth's history and climate. Antarctica is the 5th largest continent in the world, approximately bigger than the entirety of Europe or Australia, competing with the entire South America in size. Aside from East Antarctica, we discussed there are several more regions: Antarctica Peninsula, South Pole, West Antarctica, and the Ross Sea. The continent is basically a frozen sandbox, and all its hidden, mysterious landscape is actually less explored than Mars's terrain. We only know for sure that without ice, it wouldn't just be flat and empty, but an entire world full of big mountains, huge canyons, and even fiery volcanoes. Some of these volcanoes are so huge that they peak above the layers of snow. In West Antarctica alone, there are at least 138 volcanoes, though only about 8 or 9 are active today. One of the craziest ones is Mount Erebus, the southernmost volcano and the tallest one on the continent, about 12,500 feet high. And deep beneath the ice sheet, this guy hosts incredible, beautiful subvolcanic caves. The temperatures there are warm enough for t-shirts. The Antarctic Peninsula, or Lesser Antarctica, looks like a bunch of mountainous islands deeply underground. It has newer volcanic rocks that are part of the Pacific Ring of Fire. which is like a giant circle of volcanoes and earthquake zones around the Pacific Ocean. The Greater Antarctica is a huge part, almost as big as Australia. It consists of East Antarctica and the South Pole. Beneath the ice, it's a place of rocks that have been around for a very, very long time, including the special zone we mentioned. You probably know that Antarctica is nearly devoid of humans. No wonder, with a mean temperature of about -46 degrees Fahrenheit. But even though this place is horrifyingly cold and deserted, life still clings on. You guessed it, in the underworld. In 2017, scientists found DNA traces of algae, moss, and even possibly unknown small animals in the deep caves. That means that even in such crazy conditions, there are still unique ecosystems thriving in little isolated warm pockets beneath the snow. There was another incredible find beneath Antarctica's Ross Ice Shelf, a lively ecosystem vibing within an underground river. Scientists have long suspected that Antarctica's underworld should have some freshwater lakes and rivers. One day, a satellite spotted a groove there. They decided to explore it and used a hot water drill to melt their way through the ice. As they reached the underworld, they dropped a camera into one of those hidden fresh rivers. And at first, they thought they'd find just some rocks or something. But instead, they stumbled upon hundreds of amphipods, tiny shrimp-like creatures. Little ones instantly swarmed around the lens. Shrimps blocked the camera and scientists couldn't check out what they wanted to. Pretty funny, but at least that means that there really is an important ecosystem deep within Antarctica. Now, they're gonna explore it. And all this is just the beginning of the mysterious underworld. Antarctica's snow also hides the deepest canyon on Earth under the Denman Glacier. Well, Mariana Trench is still the deepest point on Earth, but it's a part of the oceanic crust, geologically speaking. Also, in 1958, explorers found a huge mountain range under the ice, as big and tall as the famous Alps Mountains. The range stretched for about 745 miles with peaks as high as 1.7 miles. And all this magnificence is buried under tons of ice. Who knows what else we might find there? Antarctica holds about 60% of our entire planet's freshwater, which means it would be pretty bad if it melted. For example, there's this Doomsday Glacier, officially known as Thwaites Glacier. It's a huge ice formation, about the size of Florida, and it's melting right now. Every year, the sea levels rise by 4% because of it. If this guy melts away completely, the sea levels all around the world will increase by 2 feet, which might not sound like a lot, but it would be catastrophic for coastal areas. Luckily, researchers have found that even if its ice shelf were to collapse in the next 50 years, the glacier itself wouldn't retreat as quickly as they feared. It's still losing ice rapidly, but it would be quite a slow process.
If all the volcanoes on Earth suddenly erupted together, it'd be loud. We'd also have around 1,500 of these formations bursting at once. Now normally it's just 10 to 20 volcanoes that are active each day. But what would the world look like if they all blew their tops simultaneously? Geologists think it wouldn't be pretty. Even if only the land volcanoes erupted together, it would set off a chain reaction way worse than anything we've ever seen before. The two big problems would be ash and volcanic gases. While the explosions in lava would be damaging for people nearby, the real danger lies in what happens next. A thick layer of ash would cover the planet, blocking out sunlight completely. No sunlight means no photosynthesis, which means crops would fade away and temperatures would drop considerably. And all this ash cloud could remain in our atmosphere for up to 10 years. Now, ash aside, there's also acid rain to worry about. Volcanic gases like hydrochloric acid and sulfur dioxide would mix with the atmosphere and fall back down as acid rain. This type of weather would harm the groundwater and ocean surfaces. Even if humans would find a way to survive up to this point, we'd have no corals and no other sea creatures around. Scientists have seen similar events in Earth's history at a smaller scale. Big volcanic eruptions have been linked to mass extinctions, When Mount Pinatubo erupted in 1991, it cooled parts of the world for 2 years. But the extra carbon dioxide from these eruptions could also heat the planet, the same way we turn our stoves to broil for that extra crispy layer on our casserole. Geologists also mentioned that there's evidence in our atmosphere that stuff like this may have happened in the distant past. During the Cretaceous period, carbon dioxide levels were way higher than today, which made it difficult for marine life to thrive. Who would survive all this? Probably just some extremophiles, these organisms that survive in harsh conditions like hot springs or deep undersea vents. As for humans, we could all lay low in underground bunkers until things clear up, or build multiple space stations that could fit us all. Yeah, right. The chances of all volcanoes erupting at once, though, are very slim. Whew! That's because there isn't one giant source supplying all the volcanoes on Earth. Each one of these openings has its own deposit of magma, except for a few cases where they indeed share the supply. For example, in 1912, Nova Rupta in Alaska erupted alongside another volcano sharing magma. Scientists have also found evidence of magma hiding under volcanic areas, like under the Taupau volcanic zone in New Zealand. This magma can spread out horizontally for long distances, but is still just a local feature. Even if we consider all the magma under Taupau as one system, it's not connected to other volcanic areas like Indonesia or the Philippines. Because the great majority are isolated, volcanoes can't sync up to erupt at once. The magma comes from different processes like mantle decompression or adding water to the mantle through subduction. There's no way to make all these different volcanoes erupt together because of how tectonics work. Now, that doesn't mean we won't see interesting volcano activity in the future. Take an underwater area near British Columbia, where recently about 200 small earthquakes per hour have been noted. Deep beneath the Pacific Ocean floor, off the coast of Vancouver Island, magma is set to erupt, heating the water so much that it'll bubble like soda. However, this event will likely go unnoticed by anyone other than scientists. The anticipated eruption will most likely happen around 3 miles below the ocean surface. Scientists explain that the earthquakes range from negative to 4.1 magnitude, meaning only those nearby would feel any tremors. This unusual activity gives us a rare opportunity to study how the Earth's crust forms. The magma beneath the ocean floor is estimated to be almost 1,500 degrees Fahrenheit, but will cool rapidly upon eruption and contact with water. This runny rock will solidify upon contact with the seafloor, turning black quickly. This event will be useful for biologists too, who will have the opportunity to study the marine animal's response to any changes, like run! Antarctica, often seen as a vast icy continent, also holds a volcanic surprise beneath its frozen surface. Researchers have identified over 130 under the western ice sheet alone, making it the largest volcanic region on Earth. Most of these volcanoes, about 90, were only recently discovered in 2017. But could any of these Antarctic volcanoes actually erupt? Well, it depends on which volcano we're talking about. While these formations are relatively young in geologic terms, it's hard for scientists to tell if they're still active or not. There are only 2 confirmed active volcanoes in Antarctica, Deception Island and Mount Erebus. The latter, standing tall as the highest peak on the continent, has been continuously erupting since at least 1972. It's known for emitting gas and steam, and sometimes even throwing out rocks in what are called strombolian eruptions. One of its most notable features is a persistent lava lake in its crater, a rare phenomenon due to specific conditions needed to keep the surface molten. For instance, it's fueled by a steady supply of magma from deep within the Earth's mantle. This continuous inflow of molten rock provides the material for the lava lake to exist. It also features low ambient temperatures. Despite its location in Antarctica, Erebus has relatively mild temperatures in its summit region because of the heat generated by the volcanic activity. This allows the lava lake to remain liquid rather than freezing over. Deception Island, another active volcano, last erupted in the 70s. While it's currently not showing signs of imminent eruption, It's being monitored closely for any concerning activity. Apart from these two being confirmed to be active, Antarctica is dotted with fumaroles, openings in the Earth's crust that release gases and vapors. Sometimes these fumaroles can create icy towers reaching heights of 10 feet. What we should focus on is maybe supervolcanoes. They're this type that has the potential to produce the most massive and destructive eruptions. Unlike the typical one, which has a single vent, supervolcanoes have a vast magma chamber beneath the surface, spanning tens or even hundreds of miles in diameter. Their eruptions can have catastrophic effects on the surrounding area and even impact global climate patterns because of the amounts of ash and gases they spill out into the atmosphere. One famous supervolcano is the Yellowstone one, which some say is gearing up for another eruption. It has the capacity to unleash a colossal eruption, spewing over 240 cubic miles of material. As much as we'd like to predict its behavior, volcanoes don't stick to a calendar. On the contrary, eruptions simply happen when there's enough magma beneath the surface. There also needs to be enough pressure for the magma to travel upwards. As far as we can measure, these conditions are not currently met at Yellowstone. Sure, many volcanoes operate on a cyclical pattern, but that doesn't mean Yellowstone is overdue. In fact, Yellowstone has had just 3 major eruptions over the past 2.1 million years. Also, the term supervolcano refers to the formation's size, not necessarily how fussy it is. Yellowstone's monitoring is extensive, tracking seismicity, ground deformation, thermal emissions, gas, water chemistry, and surface changes. Signs of an eruption would include thousands of earthquakes over a short period. We'd also see deformation on the ground and weird gas emissions ahead of time. Stable, as it might look like for now, the consequences of it having a major eruption could look ugly. Ash dispersion could blanket a 500-mile radius, potentially disrupting Midwest agriculture and clogging waterways. Ash and gas emissions into the stratosphere could induce global climatic effects, making our planet colder for several years. And yes, we've seen some research that it shows there's more liquid molten rock under the Yellowstone volcano than scientists believe. But that doesn't translate to imminent danger.
These dark patches on Greenland's ice sheet aren't just any old stains. Every summer, the ice, which is usually bright white, turns murky gray in certain areas. This so-called dark zone was a huge mystery for a long time, until some studies discovered that this weird transformation was connected to the odd appearance of red, green, and brown-colored algae. The scariest part is that this algae bloom keeps growing. The dark zone is getting darker, and terrifying microbes might start appearing. Now, the rest of the world should be concerned. The Greenland ice sheet is like a massive ice blanket that covers around 80% of the island. It's so thick that it holds about 8% of the world's freshwater ice. For most of the year, the ice looks like a giant untouched white sheet stretching over the land. But when summer rolls around and temperatures start to rise, things begin to change. The ice melts, revealing rocky areas along the coast. And as you move further inland, that once smooth white ice becomes darker. This is the dark zone, and it covers an area of around 248 miles in length and 62 miles at its widest point. This weird phenomenon happens basically for 2 reasons. The first one is black carbon. Just like dust that builds up on your bookshelf, the ice in Greenland has the same issue. The wind carries a mix of dust and soot to this icy area. But unlike your bookshelf, you can't just wipe it off with a cloth. In Greenland's case, this dirty mix settles on the ice and sticks around for thousands of years. So, the dark zone is basically covered in a fine layer of dust that's built up over time. Back in 2014, researchers analyzed this dirty mix and found that the darker ice areas were filled with black carbon. This black carbon didn't just appear out of thin air. Well, actually, it sorta did. Scientists believe it mostly comes from smoke produced by wildfires in northern Canada and Alaska somewhere in the past. As you might guess, black carbon is black, which is why it makes the ice look darker. Now, the second big reason for the Greenland ice sheet's summer makeover has to do with those algae we mentioned earlier. We're mostly talking about two types of it: the Ansilonema alaskana and the Ansilonema nordenskjoldii. Both of them love cold water regions. During winter, they stay in a dormant state deep within the ice. But when spring comes, they start to slowly migrate to the surface. By the time summer hits, they're ready to bloom and soak up nearly 24 hours of sunlight each day for photosynthesis and growth. Normally, these algae are green, but when exposed to sunlight, they turn brown as a natural way to protect themselves from harmful ultraviolet rays. And this color change is also what makes the ice in Greenland look darker. So far, this has been normal behavior. What's really alarming is that these algae blooms are getting bigger and bigger every year. This happens because they thrive on phosphorus, a nutrient that's plentiful out there and comes from a mineral called hydroxylapatite. This mineral is found in a type of rock that breaks down into tiny dust particles, which are then blown across the ice by the wind. As the climate gets warmer, the rocks dry out more, and stronger winds carry more dust. More dust means more phosphorus, leading to more algae growth. See? It is a cycle, and it keeps getting worse every year. Studying this is crucial to understanding why the dark zone keeps getting bigger. From the year 2000 to 2012, its size increased by 12%. But you might be wondering, why should we care? After all, it's just ice getting darker, right? Well, not exactly. Think about how you can't stand wearing black clothes on a hot, sunny day. They soak up the heat and make you feel even hotter. That's because darker surfaces absorb more sunlight. The same thing happens to ice. Together, dust, black carbon, and algae blooms are responsible for about 70% of the variability in albedo on the Greenland ice sheet. Albedo is just a fancy word for how reflective a surface is. If you take two surfaces, one white and shiny and the other dark and rough, the white one will reflect a lot of light and heat, giving it a high albedo. The dark one, on the other hand, will absorb more light and heat, so it has a low albedo. During the summer, the Greenland ice sheet experiences a reduction in albedo. This means the ice absorbs more sunlight, and when ice absorbs more sunlight, it melts faster than it should. This is why understanding what's happening in the dark zone is so important. It helps predict how quickly the Greenland ice sheet is melting and how it can affect the rest of the world. Greenland's ice sheet is the second largest in the world, covering an area about the size of all the land in the United States east of the Mississippi River. And its huge mass of ice averages a thickness of 1.4 miles. Unfortunately, the ice loss has skyrocketed. Back in the 1990s, Greenland was losing about 25 billion tons of ice per year. Now, it's losing around 234 billion tons per year. That's nearly 10 times more ice melting away each year. According to NASA, if all of Greenland's ice sheet were to melt, it would increase global sea levels by about 24 feet. That could be catastrophic for coastal countries and cities around the world. The Netherlands could be submerged, the Bahamas could be almost completely wiped out, and many of the Philippines Islands would be at risk of disappearing. All of this may seem like a distant reality, and it is true that most scientists believe it would take several hundred or even thousands of years for the ice sheet to melt completely. But it is important to know that Greenland didn't always have this thick layer of ice. Very recently, researchers took a close look at some sediment from the bottom of a 2-mile deep ice core extracted from the center of Greenland. They found that the soil had traces of willow wood, insect parts, fungi, and even poppy seeds. So these fossils are the first direct evidence that Greenland's ice sheet melted away in the recent geological past, around 400,000 years ago. At that time, Greenland was home to a green tundra landscape with insects and plants. This discovery is both fascinating and scary because it shows that the ice sheet collapsed before, and might be more fragile than scientists originally thought. There is another concern too. A recent research collected meltwater from different spots on the Greenland ice sheet and found that the water samples were packed with hundreds and thousands of microbes. The concern is that they could be released into the ocean in the future. And some studies already suggest that areas near where a lot of glacial meltwater flows have a higher risk of viruses jumping to new hosts, like from animals to humans. Even though experts believe the chance of a doomsday virus coming from the glaciers is very small, it's still not zero. The truth is, we don't know much about the thousands of microbial species living on the surface of the ice, and there is simply not enough data to fully understand how dangerous these organisms might be. All of this might sound concerning, but we shouldn't panic just yet. There's still a lot we don't understand about what is darkening the Greenland ice sheet. We still need more detailed measurements of the relative abundance of dust, algae, and black carbon, as well as a better understanding of how these potentially dangerous microbes could affect our lives. The more we learn, the better we can predict what's going to happen and how we can prepare for it. Antarctica, a snowy world of about -46 degrees Fahrenheit, covered in ice for millions of years. But it wasn't always this way. Scientists just found something buried deep beneath the seafloor that shouldn't exist. Tiny golden droplets of amber. This means that Antarctica was once teeming with life and thick with trees. But something happened to it. Something that could reshape the way we see our own future. Antarctica has been a land of howling winds for millions of years. No tree can grow here today. But scientists who studied those lands decided to drill deep beneath the Antarctic surface. They went thousands of feet below the ice, pulling up ancient layers of sediment. And there, trapped in time, they found tiny pieces of golden amber. Amber is basically fossilized tree resin. It's found all over the world, often with perfectly preserved pieces of ancient life. Insects trapped mid-flight, pollen frozen in time. Entire tiny ecosystems can be locked inside golden droplets. In every continent, but not in Antarctica. Until now. They discovered tiny specks from 0.5 to 1 millimeter in size, smaller than a grain of sand, but with huge significance. This droplet had once oozed from the bark of a tree about 90 million years ago. What's even wilder, amber is only produced by certain types of trees, the ones that grow in humid, temperate rainforests and jungles. That's when the realization hit. Antarctica used to be a rainforest. Those tiny flecks of amber, clearly seen only under a microscope, tell us a vivid story of a living and breathing ecosystem. Around 90 million years ago, during the Cretaceous period, when dinosaurs ruled the Earth, Antarctica could have been covered in lush, swampy forests filled with towering conifers, ferns, and ancient plants. Some of the fragments showed signs of damage. That means the trees that produced them had been injured, perhaps by wildfires or parasites. Though despite that, and despite the fact it spent millions of years on the seafloor, this amber was almost perfectly preserved. Solid, transparent, and free of cracks. Normally, amber buried under extreme pressure and heat just crashes over time. But this piece, it survived. That means other pieces could survive as well, and we might find more of them on the ocean floor. But this wasn't the first sign that Antarctica had once been a different place entirely. It started in 2017. A team of scientists drilled deep into the seabed near Pine Island Glacier on Antarctica's west coast. They pulled up sediment cores, long cylindrical samples of Earth that had been buried for millions of years. And it was insane. Inside these layers they found fossilized roots, pollen, spores, traces of an ancient forest that had once thrived here. And that's exactly what they'd been studying ever since then. In order not to damage anything, they had to spend years of hard work, breaking down the sediment into thousands of tiny pieces and scanning them all under fluorescent microscopes. The same team also found another piece of the puzzle back in 2020. They found more sedimentary samples from the ocean floor that pointed to a land of dense trees, rivers, and wetlands. A world that looked more like the Pacific Northwest or New Zealand. But why was Antarctica so warm back then? Well, that's all because of the atmosphere. 90 million years ago, Earth's carbon dioxide levels were terrifyingly high. It was literally one of the warmest periods in history, with temperatures soaring even at the poles. Think about it. Antarctica had no ice caps. Instead, it could have had buzzing insects and maybe even dinosaurs wandering through its forests. But in order to learn what happened to them, the team has to find more evidence. Antarctica really is a place full of mysteries. It's hard to study because it's covered in snow and ice so much that we don't even know its true shape and size. Some parts of the ice sheet are over 3 miles thick, half the depth of the Mariana Trench, the deepest trench on Earth. Luckily, snow has a great quality. It can freeze things in time perfectly. Layer by layer, year after year, it buries nature's past like a time capsule. Luckily, snow has a great quality. It can freeze things in time perfectly. Layer by layer, year after year, it buries nature's past like a time capsule. At first, fresh snow is soft and shifts easily in the wind, full of air. But as more snow piles on top, it compresses, squeezing out the air pockets and hardening into dense ice. This freezing pressure locks everything inside. It traps ancient plants, animals, and even entire landscapes. And they literally get frozen in time, because the extreme cold slows down decay. It stops bacteria growth, preventing rot, and keeping things almost perfectly intact for thousands, sometimes even millions of years. That's exactly what's going on in Antarctica. Scientists have to literally scan it all the way down this snow in order to find what this place looked like millions of years ago. What they found is an entire lost world buried under miles of ice. It was beneath the thickest ice of East Antarctica, near the Aurora and Schmidt subglacial basins. The weight of the ice has been so immense for so long that it actually protected the land from erosion. Scientists call it the ghost of Antarctica's landscape, and it's nothing like the smooth, flat wasteland seen from above. They found rivers that once flowed freely, now frozen in place, valleys carved by water, even 3 massive, sharply peaked hills. But what are they? To understand that, we need to go even further back in time, to the era when Antarctica was still part of a lost supercontinent. Hundreds of millions of years ago, the land we now call Antarctica was part of Gondwana, an enormous supercontinent that included South America, Africa, India, Australia, and Antarctica all fused together. But as Earth's tectonic plates slowly drifted apart, Gondwana broke into pieces. Antarctica was ripped apart, its land stretched and fractured. The massive ice sheets that formed later covered these broken landmasses, preserving them like frozen fossils. As the ice shifted and melted over time, valleys formed, and ancient rivers likely carried water toward a coast that was hundreds of miles away from where it is now. But that's not the only thing Antarctica has hidden. If you stripped away the ice, you wouldn't see a smooth, empty continent. You'd see a super dramatic landscape, towering mountains, deep valleys, even fiery volcanoes. In West Antarctica, at least 138 volcanoes are buried under the ice. One of them, Mount Erebus, is still active. And inside, it has warm volcanic caves where you could walk in a t-shirt. Oh, and if it wasn't weird enough, Erebus is also spewing out gold. Yep, the actual tiny specks of gold from deep within the Earth. Scientists believe this happens because magma, the superheated semi-molten rock beneath the Earth's surface, carries liquid gold with it as it rises. Every single day, Erebus releases about 0.2 pounds of it. That's worth around $6,000 per day. In a year, that adds up to 64 pounds, or more than $2 million, floating into the sky. Unfortunately, before we grab shovels, we gotta remember that those are just microscopic particles. They're often smaller than 60 micrometers, thinner than a human hair. Not even mentioning that they're scattered around up to 620 miles away from the volcano itself. Finding them is nearly impossible. But that just shows that even in such a harsh place that looks just like a white desert, there are still many fascinating mysteries to discover. For example, somehow, life still clings there. In 2017, scientists drilled deep beneath the ice of the Ross Ice Shelf looking for water, but they found something fantastic instead. A river hidden beneath 1,640 feet of ice, running through the dark. And inside it, hundreds of tiny shrimp-like creatures. They swarmed around the camera, blocking the lens, welcoming the scientists. In deep caves beneath the ice, DNA evidence has also shown traces of moss, algae, and possibly even unknown tiny animals. So, turns out, even in one of the harshest places on Earth, life finds a way. And who knows what else we'll discover in the South Pole? Scientists discovered something Atlantis-like near Australia. There used to be an entire continent that's now underwater. Here's what happened to it. Around 70,000 years ago, during the last ice age, there was a huge landmass called Sahul. It was located in the southwestern Pacific Ocean. This ancient supercontinent connected what we now know as Australia, New Guinea, Tasmania, and the Aru Islands into one giant piece of land. Imagine lush tropical rainforests surrounded by beautiful mountains. Sahul's tallest mountains were in the New Guinea highlands, with peaks reaching over 13,000 feet. This beautiful place was home to a variety of unique animals, most of which were pouched creatures. But back then, they weren't just koalas and kangaroos. Sahul was filled with different types of grazers, burrowers, scavengers, and predators. It was home to a huge diprotodon, a powerful hunter Thiosolio, and a horrifying Megalania, a creature that's much larger than any living lizard today. It was a unique place because the rest of the world was filled with placental animals at the time, like wolves, elephants, and humans. In Sahul, the only normal mammals were bats and rodents. But not all its parts were the same. The Timor, Arafura, and Carpentaria regions were covered by hot savanna and dry forests. It looked kinda like modern Australia, hot air deserts with scrubland, steppe, and temperate forests along the eastern coast. Back then, people were migrating all across the world. They made an incredible journey from Southeast Asia to Sahul and first arrived here from 60 to 45,000 years ago. They mostly traveled by foot and crossed the sea using bamboo rafts and simple boats. They came there from an ancient landmass called Sunda, which includes parts of Southeast Asia. They traveled across a series of islands known as Wallachia and eventually spread across Sahul. And it wasn't a small journey. Sahul was huge, around 4.1 million square miles. That's bigger than the USA or Canada. It stretched from the equator to around the southern part of New Zealand. So they arrived in what is now Australia and became Australia's first people. Scientists think that Sahul had a population of 500,000. We've discovered cave paintings that date back around 40,000 years. It's a hunting scene depicting an anoa, or miniature buffalo, facing figures of humans and animals. Researchers are trying to figure out how these early settlers moved across Sahul and where we might find archaeological evidence of their journey. To do this, they created a landscape evolution model. The simulation showed how Sahul changed between 75,000 and 35,000 years ago. It showed potential migration routes and archaeological sites. Humans likely traveled along coastlines and rivers. But how did Sahul get submerged off the coast of Australia, similar to the mythical Atlantis? During the last ice age, much of the Earth's water was locked up in large ice sheets and glaciers. The sea levels were much lower than they are today. After that, the global temperatures increased. The ice sheets melted and the sea levels rose, flooding the land bridges that once connected different parts of Sahul together. About 8,000 years ago, New Guinea separated from mainland Australia, and then, about 6,000 years ago, Tasmania did the same. We still can explore the underwater parts of Sahul thanks to new technology. Divers explore and collect samples directly from the ocean floor. Underwater drones can go to places that are too deep or dangerous for humans to explore. And with sonar mapping, scientists use sound waves to create maps of the ocean floor. It's like using an echo to see what's underwater. The sound waves bounce off the seabed and come back, helping us create a picture of what it looks like. Deep underwater, archaeologists have found stone tools and other artifacts. They also discovered fossils of animals like Diprotodon and Thylacoleo. By studying the underwater terrain of Sahul, they learned about the ancient rivers, lakes, and coastlines that existed during the Ice Age. But Sahul isn't the only underwater continent. Sahul isn't the only hidden gem of Southeast Asia. Take Sundaland, a place made up of Sumatra, Java, Borneo, and some other islands. This place was crazy huge during the Ice Age, but now almost fully underwater. Almost, but not entirely. The parts above the ocean are teeming with life. If you like birds, check this place out. It has almost a fifth of the world's bird species. You can spot colorful birds like the Java hawk eagle and the Bali starling among the lush forests. It's also a home to a fourth of Earth's fish species. Sundaland's waters are a haven for marine life, even the most exotic animals like the Asian arowanas. It's also a treasure trove of flowers. That's where you can find Rafflesia and Titan arum, the world's largest flowers. This makes it very similar to Zealandia. Zealandia is a long, narrow piece of land about half the size of Australia. It broke from Antarctica about 100 million years ago. Just like Sundaland, it isn't fully underwater. 7% of it stayed above sea level. This sticking out little piece is what we now call New Zealand, along with Stewart Island and some smaller islands. These pieces of Zealandia are lush and warm. They're packed with volcanoes, mountain ranges, beautiful natural geysers, and hot springs. Local people, Maori, use these hot springs for cooking. People place corn, eggs, and vegetables in baskets and lower them directly in the hot springs. Sometimes they cook food in a pit oven using heated rocks. Another hidden world is known as Argoland. This mysterious landmass was once part of Australia, back when dinosaurs chilled around. It drove scientists crazy for decades. They knew it existed because it left a huge stretch on the ancient seafloor, the Argo Abyssal Plain. About 155 million years ago, it broke off from Australia, saying bye-bye. The continent drifted somewhere north, and when it reached Southeast Asia, it just vanished. Scientists had no idea where it went, but recently they finally found its remains. Turns out, poor Argoland's lower parts started drowning into the Sunda Trench, a horrifyingly deep oceanic pit. The Earth's crust sunk into the mantle. Meanwhile, the upper parts of Argoland were pushed upward, grabbing the younger rocks on land. Because of this, Argoland broke apart into a bunch of smaller pieces. These pieces formed parts of Borneo, Java, Sulawesi, and other regions. The remains are buried under Indonesia and Myanmar. Imagine a colossal landmass the size of Greenland, Greater Adria. Its journey began about 240 million years ago when it broke away from the supercontinent Gondwana. It started moving north, and after 100 million years of enjoying the warm seas, it suddenly crashed into Europe and shattered into pieces. Most of these pieces went deep into the Earth's mantle, but some were scraped off and became part of mountain ranges like the Alps. Today, the remnants of Greater Adria are scattered across more than 30 countries, from Spain to Iran. That's why they're hard to look for. Seychelles was also once part of Gondwana. Yep, these idyllic islands are sitting atop of the ancient continent. We know a lot about it because of its fascinating granite outcrops. 100 years ago, Alfred Wegener discovered continental drift, but no one believed him. These granite outcrops helped him prove that he's not crazy and that tectonic plates really are moving. The Seychelles broke off from India and Madagascar and eventually became a sad loner in the Indian Ocean. This probably happened because of some insanely active volcanoes in the Deccan Traps. But now, the islands are home to unique species both on land and in the coral reefs nearby. Mauritia broke off from India after the dinosaur wiping. Along its journey, it stretched into a long ribbon-like shape and also broke into pieces. Now it's all scattered beneath the Indian Ocean. Scientists stumbled upon this lost land by studying tiny ancient crystals called zircons. These zircons are like time capsules. They date back an astonishing 660 million to 2 billion years. That's even older than Mauritius itself. These ancient crystals hinted that there's another Atlantis somewhere nearby. Turns out there are hidden continents all around the world, and maybe we'll discover more of them in the future.
Do you know how many continents there are on Earth? That's an easy one, 7. But wait a second, aren't Europe and Asia one large continent, Eurasia? It looks so when you look at the world map. Well, scientists think differently. They don't just look at bodies of land sticking out of the sea. Geoscientists study the types of rock that continents are made from. When you see the world from their perspective, the number of continents actually increases. Yes, they are not a myth. Lost continents exist, or at least they used to. They are hiding under other land masses. Peekaboo! Researchers have recently discovered one continent just like that. It's called Greater Adria. Sound familiar? Yes, it has something to do with the Adriatic Sea. This lost continent is completely buried under Europe. It collided with Europe and started to sink under it a long time ago. Today, it lies beneath Italy, Greece, and the Baltics. Its size and even shape match that of Greenland, the world's largest island. But how did geoscientists find Greater Adria? It's no longer visible, but it left some clues. Parts of it were embedded in the Alps. Other chunks were incorporated into present-day Italy and Croatia, on the other side of the Adriatic Sea. Limestone rocks from the former continent started to change once they were under the European landmass. Tremendous heat and pressure spread over tens of millions of years changed their structure. Out goes the limestone, in comes the marble. All the Greek and Roman temples you admired on your summer vacation were constructed using this marble. It was sort of a going-away gift from a long-lost continent. Greater Adria camouflaged itself well for thousands of years, but other lost continents were hiding in plain sight. Have you heard of Earth's 8th continent, Zealandia? Probably not, because it sits under the surface of the Pacific Ocean. 95% of Zealandia is now underwater. Can you guess where exactly? Its name is a good hint – under New Zealand. If you open Google Maps, you can see its outline. Look for a lighter shade of blue in the ocean. It should stretch from New Caledonia to New Zealand. This bump in the ocean floor used to be above sea level. It was about 2/3 of Australia and more than twice the landmass of Greater Adria in size. We can spot Zealandia today because it hasn't sunk too low, and that's the best way to discover other lost continents. Imagine the Earth without the oceans. The bottom of the sea isn't flat. There are mountains and trenches. You could put Mount Everest in the deepest of them, and there would still be 7,000 feet between it and sea level. This trench got so deep because of a geological process called subduction. The Pacific Plate got under the Philippine Plate. Earth's crust is made out of those plates that float in a sea of molten rock. Then they bump into each other, one goes down while the other one rises. That's how Greater Adria ended up under the European continent. Our planet is constantly on the go. We don't notice this process because it happens deep beneath our feet. 120 million years ago, Australia and Antarctica were a single piece of land. Yep, the coldest and one of the hottest places on Earth were once the same territory. Antarctica said goodbye to Australia, but it didn't leave empty-handed. Today, there is an oceanic plateau in the Indian Ocean. The word plateau comes from French, and it means elevated flatland. And the name of this land sounds like the title of a Hollywood movie, Broken Ridge. Long ago, it was connected to another lost continent. Scientists believe that it made a land bridge between India and Antarctica. What was this land like? The answer possibly lies in a tiny archipelago in the southern Indian Ocean. These islands are all that is left of an ancient landmass. They have a cold climate. The islands feature glaciers because they're so close to Antarctica. But in the past, the climate must have been temperate with plenty of rainfall. The animals and plants would have been similar to those that we find in tropical regions today. The lost continent's landscape probably resembled that of New Zealand. Now, while we're in the area, can you guess which continent the island state of Madagascar once belonged to? If you guessed Africa, sorry, you were wrong. Hey, don't feel bad. Look up and to the right of the map. The correct answer is India. Some 120 million years ago, I wasn't around then, India separated from the African continent and went northeast. Madagascar wasn't quick enough and ended up as an island off the southeast coast of Africa. But there is evidence of an even greater landmass, the lost continent of Mauritius. Scientists found traces of the ancient landmass under the island of Mauritius. Today, it's a tourist hotspot, but millions of years ago, it was a real hotspot, volcanoes and all. That's how scientists were able to retrace the steps of Mauritius. They found a mineral that exists in rocks which lava spews out after an eruption. The long-lost land once covered the area from Mauritius to the west coast of India. Imagine if that land existed today. It would form a great mix of Indian and African cultures. The local dishes would definitely be spicy. Now, speaking of spicy, have you had Indonesian food recently? Just 50,000 years ago, Southeast Asia looked much different. There was no Sumatra, Borneo, Java, or even Australia. Just Sunda and Sahul, two continental masses that were divided by a deep water trench. You had the extension of mainland Southeast Asia on one side and the Greater Australia on the other. Back then, Bali stood at the southernmost tip of Asia. Biologists were among the first scientists to notice the split. Species developed differently on Sunda and Sahul. That's why Australia has unique animals, such as the kangaroo, wombat, and platypus. And did you know that a giant kangaroo once roamed the island of New Guinea? That's because, up until the end of the last age, there was a land bridge to Australia. Today, the two islands are separated by the Torres Strait, but it's quite shallow, less than 65 feet. It's a reminder that this was once a single landmass called Sahul. Another ocean strait that isn't too deep separates Asia from North America. The Bering Strait sits today in the place of Beringia. This ancient landmass wasn't that big. It stretched 1,000 miles from north to south. That's just a third of the driving distance from Los Angeles to New York. Beringia was important for another reason. During the Ice Ages, it connected the whole world. Water levels were 300 feet lower than they are today. If they went even lower, you could walk from the Cape of Good Hope in Africa all the way to Cape Horn in South America. Talk about the ultimate backpacking route. Today, you can hop on an airplane and fly to pretty much any place on the globe. The world has never seemed smaller, has it? Well, it has. Some 300 to 200 million years ago, we were all one world, literally. Pangaea was a supercontinent that included all of the continents. Its name is in Greek, and it simply means all Earth. But Pangaea started to crack up. The biggest gap formed between the Americas on one side and Europe and Africa on the other. Seawater soon started pouring in, and that's how we got the Atlantic Ocean. This process is by no means over. While you are watching this video, North America is drifting further and further away from Europe at the rate of 1 inch per year. Doesn't seem much when compared to the average human lifespan, but in the end, all the continents will reconnect with each other, forming a supercontinent. And it wouldn't be the first time in Earth history that this happens. Honestly, I'm not going to wait around for that. Now, at first glance, it seems like we're on a giant raft called a continent that's just floating around on some molten lava until it hits another continent. Okay, let's make a quick stop at high school science class. Our home planet is like a cake with different layers of ingredients stacked up on top of each other. The Earth's core, mantle, and crust. Hey, where's the frosting? The cake batter on top represents the crust of the Earth, made up of 3 types of tasty rock: igneous, sedimentary, and, say it with me, metamorphic. These rocks are formed in different ways, such as from solidified lava or from the deposits of particles and minerals. The crust is what we stand on, a home to our continents, oceans, and everything we see around us. Then you have the mantle, not the baseball player, the layer that lies right below the crust. Many people think that the mantle is just lava, but it's not quite like that. Just like how you mix different ingredients in the cake batter, the mantle is made up of different types of rocks that are constantly moving and shifting. And finally, we get to the sweetest part of the cake, the center, or in the case of Earth, the core. It has 2 parts, the outer and inner core. The outer core is made of molten rocks and metals that are incredibly hot. Ow! Even hotter than the surface of the sun. The inner core is solid, even though temperatures there are crazy. It doesn't turn into liquid because the pressure down there is amazingly strong. When you see all this, you can easily think that below us there are endless miles of lava and hot rocks. So, how come tectonic plates move at all? The continents don't float on a sea of molten rock. The oceanic and continental crusts really sit on a mantle. Sure, there's a layer of liquid rock in our planet, the outer core, around 1,800 miles below the surface, but it's separated from the surface by the mantle that's thick and solid. So, the Earth's tectonic plates move around because they're on a thick layer of solid rock, the upper mantle. Basically, this rock is under incredible pressure and heat, which makes it flow in slow motion over time. Think of it like honey or syrup that you pour over your cake layers. As you move the cake around, the honey or syrup will also move and flow. Similarly, the upper mantle can flow and drag the parts above it along, just way slower than honey. And the rock is both breakable and flexible. It can crack and break like a cookie, now I'm getting hungry, but it can also stretch and bend like a piece of taffy. When the plates get caught on each other, they can't move anymore. But when they break free, they start drifting again, like puzzle pieces shifting around until they find their perfect fit. Extremely high temperatures and pressure are the reason this flow happens. It's like a big pot of soup on the stove. As the soup heats up, it starts to move around, carrying heat from one spot to another. Is it lunchtime? And speaking of lunch, lava, it's not just molten rocks that travel all the way up from the outer core to volcanoes. When tectonic plates come together and one slides underneath the other, they create a lot of heat and pressure while grinding against each other. It's like rubbing your hands together fast and they start to get hot, or when you start a fire with rocks. And as the melted rock, or magma, rises to the surface, it can create volcanoes. Now, long ago, the Earth's land was not divided into continents as it is today. Instead, there was one giant landmass known as Pangaea, meaning all Earth in Greek. Whoa! Imagine being stuck in the middle of this giant ocean. So, over time, this supercontinent slowly broke apart. Its parts drifted away from each other and formed the separate lands we call continents. This idea first popped out in the 16th century when one cartographer realized the coastlines of Africa, America, and Europe appear like they could fit together like puzzle pieces. Later, researchers realized the rock composition of their coastlines was similar, which means they used to be part of one giant mass, and they call that the theory of continental drift. At first, people were pretty skeptical about that idea because they didn't know how such massive lands could move around. Now, we'd all be able to explain that part, right? So, the Earth's crust is divided into a couple of large plates and many smaller ones. All of them are still moving, even though it's in slow motion. We can't sense it, and we won't see any particular changes during our lifetime. It's a process that lasts hundreds of millions of years. As the plates move, they interact with one another in fascinating ways. For example, when two plates collide, one may be forced beneath the other, which would help create a subduction zone. Over time, this is the way you get many cool things like volcanic islands, trenches, and even entire mountain ranges. Plates apparently started moving around 3.5 billion years ago. It took them a while to group into the first jigsaw supercontinent we know about called Ur. Today, its remains make up parts of Madagascar, India, and Australia. Pangaea formed 335 million years ago, but it probably won't be the last continent that will form. So, some new generations in the distant future could live on something called the next Pangaea. When the oceanic crust of the Atlantic Ocean slowly takes its place under the continental crust, the oceanic basin of the Atlantic is going to close, which is why the continents will end up pulled together. This means the Americas will meet Africa, and Eurasia will be flipped on its side. So, people might live on a giant landmass in the shape of a ring, clustered around the inner sea, or at least what's left of it. Or maybe continents will take another direction and make up a different jigsaw puzzle called Amasia. In this scenario, the Americans will drift westward, fuse with Australia, and pivot to around Siberia. And then there's more. Novo-Pangaea is the option where the Americas swing together to embrace Antarctica and Australia, and Africa legs off to the northwest. Basically, all continents here get together to form a giant landmass that stretches from one pole to the other. Ready for one more? Nah, come on. A recent projection called Eureka gives an idea similar to Novo-Pangaea. It's just that all continents here unite to become one gigantic land that clusters around the equator. Maybe this would be my favorite one to live at, with the sunny weather and the beach all the time. And who knows what kind of magnificent trenches, mountains, islands, and other geological beauties we'd get with this giant supercontinent. Pangaea broke up about 175 million years ago. As the Atlantic and Indian Oceans began to widen towards the east, the Ring of Fire was formed. It's a path that goes along the Pacific Ocean with so many frequent earthquakes and active volcanoes. This way, Eurasia was unable to cross this border and continue moving westward. And now Eurasia could move laterally along the Ring of Fire. The subduction zones kind of act like a barrier that forces the tectonic plates to move in different directions. So Eurasia could eventually collide with the Americas and form something similar to Amasia. It would be cool to sit there, grab the popcorn, and watch it from the side. But this is something that won't happen for the next 50 million years at least. I'm willing to bet I probably won't be here to see it. Different theories talk about different positions where this new supercontinent might end up one day. But it seems it will probably be somewhere in the polar area, centered on what we today recognize as the Arctic Ocean. Not my cup of tea. Bring me back the sunny one. Wait, scratch that. Let's go eat.
You could wake up in New York, grab a bagel for breakfast, hop on a train, and by lunchtime, you'd already be in London enjoying fish and chips. What sounds like every tourist's dream could be a reality soon. Right now, traveling between these two cities usually takes about 8 endless hours by plane. But a high-speed train zipping through a massive transatlantic tunnel could make the same journey in just 54 minutes. The plan is to construct this train beneath the Atlantic Ocean, So the stations would look like those trendy underwater restaurants. Not only would you get to Europe in record time, but you wouldn't have to deal with jet lag or feel sick from turbulence. So far, this mega project sounds amazing, but can we really pull this off? Well, that's the million-dollar question. Actually, it's more like a $20 trillion question. That's how much this train and its futuristic underwater stations would cost. It's hard to imagine anyone having enough money to construct it, so specialists thought it was out of the question. But people started feeling hopeful again when Elon Musk dropped this announcement. He said not only is this kind of transportation possible, but his company could make it happen for 1,000 times less than everyone thought. Traveling between New York and London in less than an hour means the train would have to hit a jaw-dropping speed of 3,000 miles per hour. Yep, 3,000. That's about 5 times faster than the cruising speed of a commercial airplane like a Boeing 747. So, how is this even possible? Well, it's not an average tunnel. We're talking about a vacuum-sealed tube underwater, which cuts out air resistance, letting trains zip through at insane speeds. And it's not just any train. It's more like a high-tech aerodynamic capsule that levitates and moves thanks to magnetic propulsion. At least that's what experts think, since this kind of technology is already in use today with the fastest public train in the world, the Shanghai Maglev. This machine runs in China and hits a top speed of 186 miles per hour. What's crazy is that its locomotives are not even touching the tracks. They're literally levitating and floating just about 0.4 inches above the ground. This line takes people from Shanghai to Pudong International Airport, so travelers don't have to worry about traffic and can get to their flights super fast. This cutting-edge technology makes a 19-mile trip take just 8 minutes and 10 seconds. With a regular train, that same journey would be about 4 times longer. Back in 2001, people worked hard over 2 years to construct the maglev train, and they also spent a lot of money, as the whole project cost over $1 billion. Despite that crazy initial price tag, keeping this line running is not as expensive as it might seem. It's actually cheaper to operate than regular trains. Since the maglev doesn't touch the tracks, that means a lot less wear and tear and way lower maintenance costs. On top of that, its propulsion system is impressively energy efficient. As we've already mentioned, this is the fastest operational train in the world, but China isn't stopping there. They're likely to break their own record soon, having already unveiled a prototype of their next generation train, the CR450. This sleek silver bullet had reached test speeds as high as 281 miles. If this project comes to life, if people really start using it on a daily basis, it will be a game changer for high-speed rail. And it could shrink the journey between Beijing and Shanghai to less than 3 hours. That's like 1 hour less than what people take when traveling on today's high-speed train. Now, the team just needs to run a couple more tests to ensure it meets all necessary standards for commercial operations. This car looks like a Batmobile, and it's probably just as powerful. Say hello to the amazing Koenigsegg Jesko Absolute. Its sleek, futuristic design isn't just for show. Every detail on this machine was crafted to cut through air with precision, reducing drag and turbulence while boosting its high-speed performance. Experts ran the first computer simulations, and the Jesko Absolute hit an astonishing 311 miles per hour. But the team is positive that it can go even faster. This beast comes close to the cruising speed of small jets, and because of that, it smashed all records and became the fastest car in the world. When you visit the Coventry Transport Museum in England, you'll come face to face with a terrestrial vehicle that looks more like a rocket than a car. Meet the Bloodhound LSR. It's been on display since 2019, right after hitting 628 miles per hour during tests in South Africa's Kalahari Desert. But the team behind this vehicle isn't satisfied just yet, and they're 99% sure they can go even faster. So, They're planning to bring it back to the track soon, aiming to smash another record. But there's a catch. The team is still looking for a fearless, skilled pilot who can handle speeds over 800 miles per hour. And before you rush to sign up for the challenge, let me remind you, it's going to take more than just guts. You will need a major sponsorship deal too, because getting back this vehicle on the track and breaking that land speed record could cost around $15 million. If you're curious about the fastest jets in the world, look no further. Meet the North American X-15, a legendary aircraft that flew for nearly 10 years and set an unofficial world speed record of 4,520 miles per hour. This beast is so impressive that it actually reached the edge of space during its test flights in the 1960s. Yep, astronauts territory. To put that into perspective, commercial airplanes, like the ones we fly in, usually travel at altitudes of up to 42,000 feet, but the X-15 soared more than 354,000 feet. Now, imagine flying faster than ever before, zooming through the sky at over 5 times the speed of sound. That's exactly what NASA did with this revolutionary aircraft, known as the X-43A. This airplane is scramjet powered, which basically means it's an engine that operates at a supersonic level. I mean, it doesn't have any moving parts like regular jet engines do, like turbines. Instead, it uses the plane's speed to push air into the engine. The air gets compressed or squished by the plane's fast motion, then mixed with fuel and burned to produce thrust. For non-experts, this might seem crazy, even dangerous. In fact, we should mention that the first flights of the X-43A weren't exactly smooth sailing. The initial attempt happened back in June of 2001, but the airplane was destroyed after the booster rocket went out of control. Thankfully, the second and third attempts were a huge success, with record-breaking flights that made history. I know elevators aren't the first thing that comes to mind when we think about super-fast means of transportation, but it's only thanks to ultra-modern high-speed elevators that skyscrapers as tall as the Burj Khalifa and Taipei 101 became accessible. One of the fastest elevators in the world is located in the Shanghai Tower in China, which has 128 floors. To get people from the ground floor to the top of the building quickly, the elevator has to move at an incredible speed of 67 feet per second. That's faster than Usain Bolt at his top speed, but just a little slower than a cheetah. Still, it is super fast, about 5 times quicker than the elevators we ride in most buildings. So if you're afraid of heights, speed, and tight spaces, we suggest you avoid going that far.
Beneath the thick, shadowy canopy of a prehistoric rainforest, a silent hunter slides into the murky river waters. This is Titanoboa. Its size is horrifying, stretching over 40 feet long, which is about the length of a school bus, and weighing as much as a small car. It reigns as the largest snake ever known. This is around 60 million years ago. It's only been 6 million years since the dinosaurs were wiped out by an uninvited asteroid. Nature is slowly returning to life, the Paleocene epoch. Titanoboa's home is lush and sweltering. The air is very humid, like in a steam room, and the rivers are teeming with fish, perfect for a predator like this. Now that the dinosaurs are gone, Titanoboa becomes the queen of hunting. It's perfectly built for both power and stealth. A strong, sturdy spine can hold the snake's massive size while staying smooth and silent. Titanoboa glides through the water like a shadow, barely visible. It doesn't chase. It doesn't need to. Titanoboa waits beneath the river's surface, in darkness. A bunch of ancient lungfish meanders too close. With one surge, it lunges, its jaws snapping shut. The fish doesn't stand a chance. Titanoboa's grip is unrelenting. After the prey stops moving, the snake immediately consumes it whole. For millions of years, this snake ruled the rainforests. Nothing could challenge it, not the prehistoric crocodiles, not the small mammals, not even the birds. But, as it turns out, it wasn't the only apex predator. Alongside Titanoboa, there was this entire family of snakes, a huge biological tree full of snake genomes and species. Their history spans around 100 million years, all the way to the Cretaceous period. We find their fossils all over South America, Africa, India, and Australia. That's because they evolved in the Gondwanan continents. Back then, all of this was one huge landmass, and they lived right in the heart of it. Now, this family coexisted with all the dinosaurs. The dinosaurs ruled the world back then, and the snakes couldn't be all that dangerous. They lived in the dinosaur's shadow, adapting to survive. Some of them fed on small mammals. Others waited for the dinosaur eggs to hatch. Some were super bold and went straight for baby dinosaurs. Fossils of one species showed the remains of a little titanosaur, that giant long-necked dinosaur, inside its stomach. And when the age of dinosaurs finally ended in a fiery cataclysm, it was time for these snakes to celebrate. After the asteroid disaster, the world entered a new era of heat and humidity. The warmer the climate, the easier it is for cold reptiles to thrive. Snakes, including Titanoboa, grew larger than ever, but so did the members of this family. All the snakes spread across continents, growing larger and scarier by the century. And eventually, Titanoboa stopped being the only ruler of jungles. Fast forward to about 47 million years ago. Now it's the Middle Eocene epoch, the tropical lowlands of what today is Western India. A lush, swampy place, full of rivers and pools. The earth was warmer, with turtles and crocodile-like creatures basking in the sun. And there evolved the largest and most fearsome predator of them all, Vasuki indicus. Even the name feels important. Vasuki, the serpent king of Hindu mythology, a colossal snake that's coiled around the neck of Lord Shiva, strong and loyal. And the indicus part is because the snake's fossils were discovered in India. Vasuki surpassed Titanoboa and grew to a jaw-dropping length of 50 feet, like a 4-story building. It also weighed as much as a small elephant. Unlike Titanoboa, who preferred to hunt in the rivers, Vasuki mostly hunted on land, though it still could venture into the water when needed. It prowled the marshy ground with quiet, calculated movements, blending with the dense undergrowth. Vasuki also ate crocodiles, massive turtles, and even early whales in local water pools. No one stood a chance. It had immense muscles and squeezed with unimaginable force. But the snake's jaws were much scarier. Unlike Titanoboa and today's pythons, Vasuki couldn't swallow massive prey whole. Instead, it ate them alive with its teeth, just like this. Fast and absolutely brutal, it was an apex predator of its time. And don't forget that we're not talking about one Titanoboa or one Vasuki. These snakes were part of entire populations. In the Paleocene, rivers were full of various Titanoboas. Some were younger, smaller ones, fighting for survival, while the oldest and largest ones dominated the waterways, in the same way as generations of Vasuki indicus competed with each other for thousands of years. Through the years, many siblings of this family got themselves a region to rule over. For example, alongside Vasuki, this big guy was thriving in northern Africa, in what is today's Egypt. Back then, this land was full of water and swamps. Before we learn more about other snakes, this one was considered the largest, about 36 feet long. That's still bigger than today's most powerful snakes, like the green anaconda. But then, we reached the Pleistocene epoch, from about 2.5 million years ago to only 11,000 years ago. Modern humans were evolving all over the world, and now the snakes had a new problem, an even worse one than dinosaurs. While we were developing brains, in Australia, there ruled the local king of snakes. Their names also come from legends. That's how Indigenous Australians called their mythological rainbow serpent the creator of the world. It's like a problem of a chicken and an egg. Was the snake named after a deity, or did the Aboriginal people create their deity after a snake? Ancient Australians coexisted with those predators for thousands of years. They warned their children how to avoid dangerous spots, passing down stories of the terrifying serpents. In their legends, the great rainbow serpent was shaping the land, rivers, and features of the world. These legends were most likely inspired by the powerful nature of those snakes. If only they knew that these animals weren't even as huge as Vasuki or Titanoboa. Though they were still dangerous. Urlungor was up to 26 feet in length. They preferred the more green and humid parts of Miocene Australia, like waterways with lush plants around the riverbanks. And there was much more potential prey. Urlungor had a thick body as wide as a human thigh. It loved to hunt in what is today the northwest Queensland. Its fossils were found in the limestone of Riverslade. It was a fascinating find. The skull was almost intact, with teeth and everything, which is crazy considering that snake skulls are very fragile and usually don't survive fossilization. Just like snakes before it, Urlungor didn't rely on venom. It was a constrictor, quick and powerful. But at least now these reptiles weren't as brutal. Their hugs quickly caused cardiac arrest in their prey. So the end came rather quickly. Also, they no longer could swallow the prey whole, and didn't have the same sharp teeth as Vasuki or Titanoboa. So both Urlungor and Wanambi had to eat very slowly, just like pythons today. Meanwhile, Wanambi was about 20 feet long. This one had a similar head, so it could only hunt marsupials, reptiles, and other little things that ventured too close. Wanambi's domain was the waterhole. It lay coiled in the shade, motionless, its body blending seamlessly with the dusty earth. If kangaroos and wallabies cautiously approached to drink, they wouldn't even notice the predator until it was too late. The Wanambi snakes lingered in Australia for millions of years. Even when the climate and ecosystem changed, it didn't bother these guys. In fact, they thrived in Australia's cooler, drier regions. Yet, even giants fall. Time moved on, the earth cooled even more, and nature began to change. Wanambi managed to last up to around 50,000 years ago, and could have lasted longer if it wasn't for humans. The same Aboriginal Australians who once feared Wanambi eventually spelled the end for the snake. All these years of being the apex predator, only for the little apes to hunt you into extinction. But that's how evolution goes. Eventually, all the giant snakes disappeared, leaving behind only their fossils and stories like this one. Okay, what if I tell you that the extraterrestrials we all imagine as little green men may actually look like very normal Earthlings and chill in Europe? This is the Iberian Peninsula, and people living there are under suspicion. Ooh. Here's the reason. Somehow, parts of the most important artifacts that the Iberian civilization called Treasure of Volcanic are made of metal that simply can't be found on Earth, because it's metal from a meteorite. Now let's tackle this step by step. This is the artifact itself, and it's composed of 59 different objects. Bowls, bottles, and bracelets. Is there a pattern there with all those bees? In total, the find weighs around 20 pounds, of which 18 pounds are 23.5 karat gold. Now, if you're not a metal specialist, I'll clarify it for you right away. For comparison, 23 karat gold is 95.8% pure gold, so 23.5 karat is even purer. The remaining percentage goes to other metals to help add strength and durability to the precious alloy. There was also silver, iron, and amber in that set. The artifact could have been pretty straightforward, but for these two, let's call them imposters. Look at this wrought iron bracelet and this hollow hemisphere. Can you see that? Those rusty lines on the hemisphere and the overall weird color of the bracelet do stand out, since everything else is made of purest gold. This all started back in 1963, when a researcher noticed a dark leaden metal among the shiny bowls and bottles. The metal was shiny in some areas and covered with a ferrous-looking oxide that was mostly cracked. Now, just so you understand, gold does not usually act this way. Gold is one of the least reactive of all metals, so it won't even tarnish, let alone rust. To figure out where this suspicious iron came from, researchers turned to mass spectrometry, which checks out the mass-to-charge ratio of molecules. Their findings showed that the nickel in the iron is similar to that found in meteoritic iron. Simply put, the bracelet and the hemisphere are of extraterrestrial origin. Ooh. Now, the exact age of the trove is hard to determine, yet it's crucial. We need to know the exact age to see if it coincides with the start of the Iron Age in the Iberian Peninsula. If it does, then no further questions here. But if it doesn't, well, it's, at the very least, weird, if not suspicious. So there's this three-age system. It comprises the Stone Age, then the Bronze Age, and then the Iron Age. The Stone Age is of no importance here, so let's compare the Bronze and the Iron Ages. The Bronze Age began when it was realized that combining copper and tin produced a material that was more durable than either metal alone. This era was all about major upgrades in tools and weapons, but two standout inventions were writing systems and the wheel. Then came the Iron Age. This time was all about slowly bringing iron into everyday life. Iron was way easier to shape into cool designs than bronze. Now, this was a big deal because iron, especially transformed into steel, provided significant improvements in all aspects of life. Tools became lighter, cheaper, and stronger compared to their bronze equivalents. You get it? Good. So, researchers have long debated whether the treasure dates back to the post-Argaric era or the latter part of the Bronze Age. The most recent study claims that those artifacts were created in 1400 to 1200 BCE, and something really doesn't add up. First off, the Iron Age began around 500 years after these artifacts were crafted. Plus, ancient craftsmen couldn't know back then how to work with metals that landed on Earth approximately 1 million years ago. And while the dates are really hard to explain, there is a logical explanation for the craftsmanship. The theory here is that those metal workers simply had access to the fallen meteorite, and thus, they could study it well and discover its properties before using it for decorative purposes. They could have figured it out through trial and error, and once they knew exactly how to work with this extraterrestrial metal, they proceeded to adorn the artifacts with it. Plus, there were the Phoenicians, who contributed to their craftsmanship. Now, it's true that the Iberian people have been processing metal and making pottery long before the Phoenicians settled on the peninsula. But the arrival of new metalworking techniques and the introduction of the potter's wheel enabled them to produce better quality goods much faster than before. So, we figured out the extraterrestrial origins of the Iberian artifacts. But guess what? This area is still under suspicion. The reason for that is the language they spoke. You see, for most modern languages people use today, there will always be some proto-language. Say for Italian, Spanish, and French, it's Latin, hence their similarities. But wait, Iberian was largely spoken where modern Spain is, so why isn't Spanish similar to it? Well, the truth is, no language today is similar to the Iberian. Maybe only the Basque language, but it's because of some similarities found in their numerical systems. Basque is classified as a language isolate, or simply unrelated to any other known languages, and the only language isolate in Europe. The Iberian language is unclassified. While the scripts written in it have been deciphered to various extents, the language itself remains largely unknown. And look at the alphabet the Iberians had. Looks like it doesn't really belong to our planet. But hold up, this one might be a bit of a stretch. When the Phoenicians came to the peninsula, they brought along their alphabet to the Iberians. But honestly, the Iberians probably weren't keen on just copying someone else's writing system, so they tweaked it until it looked completely different. Let's just say they took some inspiration and ran with it. While linguists can guess to some extent how most characters sounded, actually translating the language is still completely impossible. The Iberian language was non-Indo-European and faded away over 2,000 years ago. And there aren't any similar languages left to help us out. Super frustrating, right? Yeah. We got over 2,000 Iberian inscriptions from tombs, coins, potteries, lead plates, and even cave wall carvings. But aside from a handful of words, we're totally in the dark about what they mean. Now, if we could understand their language, we might have learned that they were great thinkers and all, but we can only contemplate the works of art they left. Iberian culture has a lot of amazing stuff made by talented artisans. We're talking about not just metalwork and ceramics, but also detailed sculptures, textiles, jewelry, and other personal bling. But here's the catch. Making all those luxury items depended a lot on a big farming class. At the heart of Iberian society, most folks were involved in farming and taking care of livestock. Depending on where you were, the types of farming varied. For example, up in the north, they were all about growing grains, while down in Valencia, they focused on producing olive oil and other agricultural aspects. In the west, raising animals was the name of the game. Still, we don't have much information about the day-to-day lives of the many people doing this essential work. Yet, on the flip side, we know a lot about the upper class of Iberian society, who control these agricultural resources and hire the artisans. By the 7th century BCE, we start to see a group of Iberian princes who were living the good life, trading with the Phoenicians and enjoying fancy luxury items. You can spot this elite class in their burial practices. Cremation was the go-to method for funerals among the Iberians, and wealthy individuals were often found in cemeteries with all sorts of lavish goods and funerary sculptures that give us a peek into the fashion and hairstyles of the rich. Interestingly, starting in the 6th century BCE, there was a noticeable drop in the number of recognizable burials, which suggests that these elaborate funeral customs became more exclusive to a small elite. Meanwhile, the fate of the majority, farmers, artisans, soldiers, and laborers, who made up a big chunk of the population, remains a bit of a mystery. It used to be a pretty advanced civilization, but it vanished without a trace. Researchers think it could have been due to some massive earthquake, but so far, we don't know for sure. Scientists have recently discovered Leonardo da Vinci's hidden passages under a medieval castle in Italy. They followed a newly found 15th century sketch by the creator of the Mona Lisa and found one of the unexplored architectural wonders from the age of the Renaissance. Construction of the Sforza Castle started back in 1358, but it was destroyed about a century later during a local crisis. Then, in 1450, Francesco Sforza, the Duke of Milan, decided to rebuild it on the old ruins. After he passed away, his son Ludovico took over and kept improving the castle. He brought in some of the best artists of the time, including Leonardo da Vinci, to decorate its walls. We can still see Leonardo's frescoes today in the Room of Wooden Boards. While he was working at the castle, Da Vinci also recorded some historical underground passages hidden beneath the outer wall. The drawing, dated between 1487 and 1490, was found at the Institut de France in Paris. The sketch is highly precise, and it proves that Leonardo was really interested in fortification design and was great at documenting existing structures. Historical records show that Ludovico ordered the building of an underground passageway that led straight to a basilica, where his wife was buried. Ludovico married Beatrice in 1491, and they had a happy but tragically short marriage, as Beatrice passed away while giving birth in 1497. The Duke locked himself away for weeks, grew a beard, and wore only black clothes while he was mourning his beloved wife. The secret tunnel may have stretched over a half a mile and would let Ludovico visit her grave in private. It could have served as an escape route if the castle was ever under siege. The existence of the tunnels remained one of the mysteries of the Renaissance for years, as no one knew for sure they were there. But now, scientists finally uncovered the secret history. They used a combination of ground-penetrating radar and laser scanning to build up an accurate 3D model of all the structures under the castle. They found the tunnels Da Vinci alluded to in his drawings, and it looks like they may have only been a small part of a whole system of historical underground passages. The goal is to create a complete digital twin of the castle that will not only show all the preserved constructions, but also the ancient ones that are no longer visible. They also plan to add augmented reality to the virtual paths to let visitors discover Leonardo da Vinci's hidden passages. Now, we don't know if the genius actually took part in constructing the hidden passages that scientists recently discovered, but we do know about some other Leonardo da Vinci inventions. He created the first satellite-like map in 1502, long before photography or satellites were even a concept. A famous figure in Italy, Cesare Borgia, invited Leonardo to a small town called Imola, near Bologna, to create a highly detailed map for him. Back then, maps were not very precise, as no one had figured out how to show exact distances on a smaller scale. Instead, people spent a lot of time decorating them with dragons, roses, fancy castles, mountain ranges, flowers, and other artistic details. These maps look more like beautiful paintings meant to be displayed, rather than practical tools for navigation. But Cesare Borgia wanted something truly functional, and Leonardo managed to create something revolutionary in the field of cartography. If you compare satellite images of Imola today with Leonardo's map, the similarities are striking. He captured every alley, curve of the streets, roadways, and even the exact sizes of the buildings. And he did it all by hand, using just a pencil, ruler, compass, and several of his own clever inventions. To gather all the necessary data, the genius walked through the streets for weeks using a large wheel that spun as he moved, recording the distance with a cable. Using the magnetic compass, he determined precise directions. He also developed a tool called the bussola, which measured angles inside a circle. With this, he could track the exact turns of each street and the size of the intersections. He figured out the distances between houses and major roads. Then, back at home, he used his notes and calculations to draw the map to scale with incredible precision. In his work, Da Vinci also used a technique developed by Florentine humanist Leon Battista Alberti. He created a mapping method where you could place an entire city inside a circle using polar coordinates. At the center of the city, 8 straight lines met, representing the main directions of a compass. Leonardo used this system to divide the town into 8 sections. He didn't overlook even the smallest buildings, which made his map one of the most advanced of its time. The Italian genius had a big dream to build a machine that could let people fly. He studied how birds, bats, and kites moved through the air and designed a special flying machine. He believed that if he could copy their movements, humans might be able to soar like them. Da Vinci's design looked a lot like a bat, with 2 large pointed wings that stretched over 33 feet wide. He planned to build the frame from lightweight pine wood and cover it with raw silk to make it strong but not too heavy. The person flying it would lie on their stomach on a wooden board in the center. To make the wings flap, the pilot had to pedal a crank with their feet, which was connected to a system of rods and pulleys. There was also a hand crank for extra power and even a headpiece to help steer. As the person moved their hands and feet, the wings would flap and twist, just like a bird's. But there was one big problem. Humans aren't strong enough to make the machine lift off the ground. Even though it might have worked once in the air, there was no way for a person to get it flying on their own. Leonardo probably realized this, but his amazing idea still inspired flying machines that came centuries later. Da Vinci was way ahead of his time with many of his inventions, but his idea for a humanoid robot was especially futuristic. He was working under the patronage of the Sforza family, the one that had those ancient tunnels of Italy built. The genius designed a mechanical knight that could move its arms, turn its neck, and even open and close its mouth. Da Vinci had good knowledge of anatomy and the mechanics of body movements that helped him. His unusual creation used an external system of cables. A hand crank set it in motion, and there was also an internal gear-driven mechanism. About 450 years later, Da Vinci's detailed sketches of the robotic knight were rediscovered in the 1950s. Several researchers tried to recreate the robot from those sketches. In 2002, a roboticist who developed systems for NASA and Lockheed Martin took inspiration from the old notes and built a functioning model of Da Vinci's robotic knight. Another design Leonardo created for Duke Sforza was a special kind of bridge that could be taken apart and carried easily. It was made for defense forces who needed to cross rivers or moats while traveling. This bridge would swing across the water and land on the other side. It had wheels and used a rope and pulley system, so it could be set up quickly and packed away just as fast. To keep it steady, it even had a special weight to help balance it. Leonardo wrote in his notes that the bridge was light yet strong, and he designed several bridges like this for the Duke. One of his other designs was a bridge that could be built very quickly, and the defense forces would move across multiple rivers. As scientists continue to study Leonardo da Vinci's hidden passages, they reveal new chapters in human history. Who knows what other unexplored architectural structures they will find? Scientists have finally solved the Loch Ness Monster mystery. Here's the spoiler, you ready? It's not a real monster. It's probably a dinosaur that survived through the ages, or just a bunch of debris floating on the water. Thanks to many findings on the Loch Ness creature, we have proof of another story to tell you. It was 1933 when a man named George Spicer and his wife were driving along the shores of Loch Ness. That's when they saw something massive with a long neck moving across the road. It looked like a creature straight out of the prehistoric era, a dinosaur-like beast unlike anything they'd ever seen. That was the moment that Loch Ness monster theories started spreading around like wildfire. One of the most famous Loch Ness monster sightings came just a year later, in 1934, when a man took a photograph that became the most well-known image of Nessie. That's the nickname she was given. She? Anyways, the photo, known as the surgeon's photograph, showed a long-necked creature rising out of the water, and for years it convinced people that the monster was real. But years later, the truth came out. One of the men who helped take the photo confessed it was all a hoax. The photo had been staged after all. When the photo was published, it had been significantly cropped. This made the animal in the picture look much bigger than in real life, fueling the theories that the Loch Ness Monster did in fact exist. In the 1960s, one of the first big scientific attempts to investigate the mystery of the Loch Ness Monster happened. A research team took sonar equipment to the lake and spent hours scanning the waters in search of evidence of large creatures. What they found was puzzling. They recorded several objects moving deep in the loch, or lake, with no clear explanation as to what it was. Though the team didn't manage to capture anything definitive, this sighting helped fuel the belief that there was indeed something massive living in Loch Ness. After that, research about the mystery of the Loch Ness Monster kept popping up. In 1972, with the help of underwater photography, some researchers managed to capture strange images, which got people's hopes up for a minute. But the truth is, this early research about the Loch Ness Monster was far from conclusive. Now, of course, not everyone bought into the mystical, magical theories about the Loch Ness Monster. Theory 1, from a professor of zoology at Oxford University, has made it clear that the monster is a biological impossibility. Hey, my pediatrician said that about me, too. Meanwhile, he says that no skeletal remains have ever been found in the region. Plus, no fishermen have ever caught anything resembling the creature in their fishing nets. For him, this works as proof that it simply can't be real. When it comes to the famous photos of the Loch Ness Monster as evidence, well, that's pretty simple. The professor offers a more down-to-earth explanation. He argues that these images are either showing floating debris or birds, like cormorants, which have long necks and often appear to be low in the water. When people refute his suggestion, he takes us back to human psychology and explains that people often make mistakes and misjudge the size of things, especially when they just caught a glimpse of it, and even more so when they are hoping to see something specific. Now, many of those alleged photos depict an animal with a long neck and a small head, which has led some to believe that what they're seeing is a plesiosaur, a giant marine reptile that lived 215 million years ago and disappeared with the dinosaurs. The idea of a plesiosaur surviving all these years is a theory that's been around since the first sightings of the creature. But this researcher isn't buying it. He explains that no plesiosaur fossils have been found in the region dating to anything later than 66 million years ago. The idea of a prehistoric creature still lurking in the waters of Loch Ness just doesn't hold up scientifically. Then there's theory number 2, from a British naturalist who has spent over 50 years investigating the Loch Ness Monster phenomenon. His conclusion is a little less dramatic. He believes that most people who report sightings of long-necked creatures are misidentifying other animals. He suggests people think they are seeing a sea serpent. Reports of sightings from the Loch Ness Monster have been around since the 6th century CE, long before they were distilling Scotch whiskey or other explanations. Early reports of these sea serpents describe large creatures with long snake-like bodies and multiple humps. Some say the creatures were as big as boats, and many swore they saw something swimming in the waters. Many of these early sea serpent sightings may have been misunderstandings or exaggerations of normal animals in the loch, like large fish or even swimming birds. They could have been large eels, which are known to live in Loch Ness. These eels, especially when they're moving, might have given the impression of a long, undulating creature in the water. People who saw these eels from a distance, particularly in low light or misty conditions, might have mistaken them for something much more mysterious. Theory number 3 says something else. Nessie is just a series of standing waves. These happen when two boat wakes move in opposite directions, creating a big hump in the water that could look like a creature from a distance. Loch Ness enthusiasts even showed how it works, with footage from Fort Augustus, where a river meets Loch Ness. These enthusiasts had big plans to use drones with infrared cameras and special underwater microphones to search the loch. Now, Loch Ness is massive, stretching around 23 miles long and more than 700 feet deep. So, they thought they needed drones and infrared cameras to put an end to this discussion. But despite everything, they haven't found Nessie. But it's not only the Loch Ness Monster that lacks scientific explanation. There have also been scores of sightings of Yetis and Sasquatches that no one can really explain. Folks have made movies, dreaming of finding the truth about these creatures. But, according to recent research and evidence, it looks unlikely that we'll ever find definitive evidence of their existence. Science says they can explain Sasquatch sightings, and this is how. Biologists who study wildlife using camera traps, which are set up in remote areas to capture images of passing animals, have long attempted to find elusive species. These cameras detect movement and snap pictures, providing invaluable data on the biodiversity of different ecosystems. As camera traps collect more photos over time, the number of species recorded grows. However, after a while, the number plateaus, suggesting that no new species are being detected. While it's impossible to claim 100% certainty, researchers say that after significant camera deployment, it's safe to say the likelihood of discovering new species, especially large ones like Bigfoot or the Yeti, drops significantly. Camera trap studies have been running for years in regions where these creatures are rumored to live, but so far, no conclusive evidence has surfaced. Instead, the supposed proof of Bigfoot or the Yeti often comes from blurry photos or shaky videos taken by individuals who claim to have encountered them. The scientific understanding of biology also makes the existence of Bigfoot highly unlikely. Often described as a great ape, Bigfoot would have had to evolve in North America. However, great apes evolved in Africa, and the only great ape to make it to the Americas is Homo sapiens, whose ancestors crossed the Bering Strait only about 16,000 years ago. This is far too short a time for a new species like Bigfoot to have evolved. While it may be disappointing for these mysterious creature enthusiasts, the scientific evidence points firmly toward the conclusion that creatures like Bigfoot and the Yeti are more fantasy than reality. After decades of extensive scientific research, it's safe to say that yes, science has solved the mystery of the Loch Ness Monster, and it's pure fiction. So, what do you think?
This area might just be the most important spot in America right now, as it is worth over $1 trillion. There's something incredibly valuable hidden right here at Thacker Pass, and it is going to shake things up, not just in Nevada, but in the US economy and its global relations. The McDermott caldera is a massive area, about 28 miles long by 22 miles wide, stretching across northern Nevada and southern Oregon. It's in Humboldt County, a quiet, rural place with just one main city that's going to change a lot in the next 5 to 10 years. That's because they found white gold there. We're talking about lithium. And to explain why this metal is so important, we need a scale. On one side, we place a chunk of lithium, and on the other, an apple. What do you think will happen? If both have the same volume, the scale is going to tip toward the apple. That's because lithium is super light. Its density is about 0.3 ounces per cubic inch, which makes it the lightest solid you can find at room temperature. Lithium is also extremely reactive. That means it combines with other elements very easily, and it can catch fire just as easily. Mix it with water, fire. Expose it to air, yep, fire again. But when you combine its lightness with its high reactivity, you get a material that's perfect for batteries. Like the one powering your smartphone, laptop, or even your electric car. Nevada's been hiding this treasure for about 16 million years. The McDermott caldera used to be a volcanic hotspot, spewing molten rock and creating a huge lake filled with mineral-rich waters. Over time, that lake dried up, leaving behind thick layers of clay loaded with lithium. Right now, Thacker Pass Mine is sitting on one of the biggest untapped lithium reserves in the world, worth about $1.5 trillion. If everything goes as planned, they expect it to produce about 40,000 tons of high-quality lithium a year. And that's enough to make batteries for up to 800,000 electric cars. Like I mentioned earlier, this metal is the backbone of modern batteries. And with the world racing toward green energy, the demand for lithium is skyrocketing. Since 2020, its price has gone up more than 10 times, making it the most expensive battery metal in the world. That means it's way more expensive than magnesium, nickel, cobalt, and other materials used in rechargeable batteries. Right now, we're using about 1.16 million tons of lithium per year, and roughly 85% of it goes into making batteries, mostly for cars. Between 2030 and 2040, experts think we will need to double the money we're putting into production, from $94 billion to $188 billion. At the same time, investment in batteries will jump by over 200%, reaching $686 billion. Finally, by 2050, the demand for lithium is expected to be more than 10 times higher than what we're producing now. Sorry, I know that's a lot of numbers, but I just want to show how important Thacker Pass will be for the whole world. This mine is going to be key to keeping everything running. I mean, literally, since most of the future demand will be for things like cars, electric bikes, scooters, and renewable energy storage. Nevada could also be the epicenter of a global energy revolution, with the US aiming to cut pollution by 50% by 2030. A big part of that is replacing gas-powered vehicles with electric ones. And to make that happen, America is going to need a whole lot more lithium than it's producing right now. Nowadays, most of the metal used in the United States come from countries like Chile and Argentina. So if America wants to be a leader in this market, it really needs to invest more and more in projects like Thacker Pass. But there's another challenge. Finding lithium in a mine is one thing, but refining it is another story. Just like diamonds are carefully cut and shaped to bring out their sparkle and sold in rings and necklaces, something similar needs to be done with lithium. The raw material that comes from the mines has to be refined into a pure form that can actually be used in things like batteries. And China pretty much dominates this part of the market, and they're responsible for about 75% of global lithium-ion battery production. In other words, it doesn't matter if a country finds this powerful metal on its land, it will probably still need China to help refine it. So, the US is eager to strengthen its supply chain. In fact, they're so excited about this possibility that authorities have invested over $2 billion in loans into the Nevada project. Because of that, Thacker Pass could make the US a leader in lithium production worldwide. If their estimates are right, the McDermott caldera could hold nearly half of the world's known lithium reserves. It would almost double the reserves found in Bolivia's salt flats, for example, which used to hold the record for the world's largest deposit. This discovery is about to change Humboldt County for good. Those quiet streets surrounded by nature will never feel the same again. The mine will need about 2,000 workers who will probably move there from other cities. Those workers will need houses, hospitals, schools for their kids, and all the necessary services. Do you see how it's like a ripple effect? For every person hired to work on the project during construction, 6 more people will get hired in the state to support them. Thacker Pass is also going to have a huge impact on the economy, not just in Nevada, but all across the country. People expect the mine to be active for 35 years, and each year it's expected to generate over $2 billion. But here's the thing. In Thacker Pass, they'll be extracting lithium from clay, and this process has never been done on such a huge scale before. So it's kind of a hit or miss. But if it works, it could completely change the industry. Big question. Who's interested in all this? Well, we've got 3 big companies eyeing the lithium market in the US. First, there's ExxonMobil. The oil giant wants to start producing lithium by 2027, and they have plans to become the top supplier for electric vehicles by 2030. Then there's General Motors, the company behind big car brands like Chevrolet and Cadillac. They're so interested in this business that they agreed to pay $625 million for a 38% stake in Thacker Pass. And finally, Tesla. In 2023, they started building a factory in Texas to process lithium. It's all part of their plan to handle more of their supply chain themselves. Now that you know how important lithium is, you might be wondering, what if we run out? Well, that could happen, since it comes from mining and, just like gold, is a finite resource. But that doesn't mean we'd have to give up smartphones or electric cars. If we ever run out of this metal, we'd probably find new ways to produce batteries. In fact, some experts think thermal batteries could be the next big thing. They store extra energy from renewable resources like wind or solar power, which are very cheap. So they represent a new way of storing energy at a small fraction of the cost. Nowadays, they're primarily used for powering the production of steel, cement, and chemicals. Thermal batteries are also being used to heat and cool large buildings. However, more and more projects are focusing on bringing this technology into private spaces, like houses and apartments. Experts are optimistic that initiatives like these could make thermal batteries as well known as electric batteries, and they might soon become a regular part of our daily lives.